Hello everyone, in this video we are going to see lecture video on introduction to the crystallography. The first video tells about the basics of the crystallography. So first, these are the contents of the series of the video lectures. First one is what is the crystal growth and what is the crystallography. Some basic key points about these two topics. Further following by the geometry of the crystals like space group and point group of the crystals will be discussed. And symmetry, how the crystal material will be classified as according to the symmetry orientations and will be used for various applications. And x-rays and crystal will be how much is important, how much is related with this x-ray diffraction techniques or x-ray techniques to characterize the material will be discussed on the future slides. Then how the structure of the atoms and molecules will be find out, how the lattice parameter is calculated, how this the material will be used for further device fabrication will be discussed on this is lecture series methods. Now we have to go for the basics of the first key point, that is the crystal growth and crystallography. The crystal or crystalline solid material whose constitute atoms and molecules ions are arranged in highly ordered microscopic structure. It will be discussed on that known as the crystalline material. So these are the basics of the naturally crystalline materials classification. That is, you can see that the picture you can indicate that is the quartz crystal, naturally grown quartz crystal, and it is the building block of the crystalline materials. Though the structure will be differed, the atoms will be the different types, orientation will be grown attached together and forms a external forms which have the morphology. Externally it is still as the morphology. The process of the formation mechanisms under the known as the crystal growth is called as a class crystallization or solidifications. The scientific study of the crystal is formation is known as the crystallography. So that is the main point we have to discuss. Now we have to go for the bibliography about the crystallography. The father of crystallography is nothing but Ran just Huawei. It will be he will be in the year lived in the year 1743 to 1822. So these are the bibliography of the scientists who worked to develop the crystallography, and nowadays we have to using the essence of the crystallographic as a the well developed X-ray diffraction techniques in the various fields. So these are the scientists we have worked behind to develop these techniques. So one of the it has an Indian origin is Ramachandran to develop the one of the best method to identify the molecular structures or molecular related work on quantum mechanics. Next, engine origin biophysics Venkatraman will be Venkatraman Ramakrishnan got Nobel Prize about the study of the ribosome microscopic structures. So these are the main for scientists work behind the structure. These are the main key factor. The images shows the how the building blocks forms a crystal. That is, as you can see that the left top about that red dotted line with this crystals with external morphology is vary according to the growth of the direction of the molecules in this container, whatever the material, whatever the systems, that will be differed according to the different type of composition of the elements. So next you can see that it will be classified by the symmetry. Symmetry is nothing but it will having the symmetrical operations or symmetrical elements around the crystal surface, like mirror planes or nothing rotations that will be classified into the symmetry operations. Based on that, we have classified as a crystal symmetry and crystal point group and crystal class and crystal systems. So these are the example for natural example for the crystal symmetry. The flower petals, it will be uniformly around 360 degree. That is, the flower petals are the best example naturally according to symmetrical example of that symmetrical example of mirror orientation around the 360 degree of their point of the center, that is called the petals. It will be naturally occurring symmetry. Next you can see that it will be scientific study, so it will be classified as some of the angles of the phases will be calculated further fabrication of the device for further application of the material development. So next we have to see what are the geometry of the crystals. So in this class we have to see what are the basic symmetry elements will be present to classify the crystal elements. One is symmetry operations, then is the symmetry element. So reflection sigma, it is not the reflection, that is one type of element reflected to the mirror reflection, that is called as a rotation, that is called a symmetry element is nothing but plan of reflection. Next symmetry element is rotation. Okay, symmetry is nothing but it is if we do some operation or rotation, reflection, or inversion or identity, it will some we do some symmetrical operation. So material orientation is same as that original state, that is called as the symmetry operation. If it is a rotate, we can get the same image of the initial state of that object. We can say that the reflection symmetry is present on that material. So it's nothing but symmetry element. Symmetry operation is nothing but symmetry element is the mirror. So we can do place the mirror means if the mirror reflection indicate that the original state of the material of object shape, it called as a, it has the material as a mirror symmetry, that is called reflection element. Point of reflection that will be along different orientations, sigma x, sigma y, and sigma z. So these are the table that will explain the symmetry operation symmetry. Next we have to go for the images, so see how it is differed into different type of crystals according to the center of orientation. There's a different shapes and different crystals having the different symmetry operations. So next we can see that how much identify infusions of the external symmetry, and different will be the different. So macroscopic will be classed, macroscopic will be rotation, mirror, and inversion, that will be classify the external morphology of the crystal, that is called as a point group. Next microscopy, it moves not for the external shape of the crystal, so it is purely according to the atomic positions in the crystal lattice. It's a microscopic, it will be classified by the screw axis and glide planes. So it is without moving and is called as a point group or crystal class. With the translation at microscopic level is called as a screw axis and glide reflections, so that is called as a spray groups. So in this video I have stopped here. Next video we can see that what are the point group and space group in the crystal system, how it influences the atomic orientation in the crystals. Thank you.